In trivia game version 2, we will bring in numbers into the game. For example, we want to keep track the scores for each of the players, right? So for this purpose, we have to create a double integer tag. We have to use what we call the numerical instruction and also numerical HMI component or display, or the new component we learned from the previous lectures. All right. So before we begin, we want to have a base to work with, right? Because we already have the version 1, so we want to build upon the version 1. So notice here, I ask you copy paste the design by large. Remember, on version 1 we have two different type of design, either by large or by OTE, right? So I ask you to copy and paste the by large instruction design, right? I have my reason for that. I just want to talk about this before we move on to the next step. So the reason I want you to copy from the large design is that if you remember, integers instruction, I'm talking about move, but actually it's the same for the compute, right? Because compute is just math operation plus move, right? So we did a comparison between the move and OTE, OTL, OTU. So you can see with this, basically they are doing the similar thing. They all set the tag values, right? Remember OTE, OTL, OTU, they just set the tag value because they operate on Boolean tag. They only can set or reset with two different values, either 0 or 1. But with numerical instructions, we are talking about numbers, right? So countless options, right? Because numbers, you can set up anything, right? So this is the difference, but they are doing the same thing. They are just set the value for the particular tag, right? It's just because the target is different type, then the options are different, right? So this is the first one we talk about. Then the after that, this is the reason, right? So integer value is returnative. Returnative, that means it will stay. It will stay there until you override it. Remember, when we move value to the double integer tag, move to the target, the number will stay on the tag, and then you assign that tag to a different value. So in this way, it's very, very similar to OTL, OTU. Compare with, if you have to compare them on this perspective, it's very close to OTL, OTU. Sorry, because OTE, once you move energize the bit, if the condition become false, automatically it will convert back to OTE to 0. OTE with OTE, but with the numerical instruction is returnative. In this perspective, in this point, it's very close to OTL, OTU. The only of course they are different, right? OTL, OTU will keep the value even the PLC lose power because the battery backup, but with the integer, it will lose the value. It will start to 0 once your PLC lose power. So there are some similarity and also differences between them, right? But overall, it's very close to OTL, OTU with the double integer numerical instruction. So that's why I asked you come back over here. The reason at the beginning, I want you to copy paste from the large and large design from there. All right. Then we start to the first part 1. We first add the scores on each player, right? So with the scores, we have 3 different scenarios. First, judge will have the crack button. All right. So let me bring up the demo. All right. Okay. So on this version 2, we have the judge crack button or wrong button. So with the correct button, we'll add 10 points to the score. With the incorrect, we'll deduct 10 points. With the fall, you have a 5-point deduction for these scores, right? So that's the requirement for the game. And then let's look at the demo, right? All right, let me okay. So at the begin, just press the button, right? Game start, and player 3 got the yellow light, and same as before, right? The other 2 players cannot get yellow light. Then judge said, okay, it's correct, get 10 point, right? But if judge said wrong answer, we'll deduct 10 point, right? So as you can see, this is not perfect as the game show, because you already deduct, and then you can deduct more than once, but that's not our concern. So with this, we just practice on the numerical operation, right? So if you want to improve on that, you can go ahead and improve on this logic. You need to add more tags. It's more involved with different steps, right? Once the judge gave the award a point, you cannot change it. But again, that's not our main concern, right? So if the player jump start, right? So game haven't started, right? Player 1 get a fault, immediately minus 5 points. Same thing for the other 2 players, right? They can potentially all get a 5-point deduction because of the fall, right? So this is the result, and let's look at the design. So as you can see, that's the copy from the version 1. Then we add more logic on top. So over here, I only show you at 10 point, right? So the 10 point, obviously we need to use add instruction. And then one thing is on here, you have to insert a one shot, right? Over here, I add one shot after the correct button, but if you have you separate them into 3 different players. For example, you insert between these 2 instructions, then you need to have separate one shot and separate tag. Right? It really depends on how do you organize your program. So you're going to use a lot of one-shot instruction. Remember, we talk about every time when you use one-shot instruction, you have to use a brand new tag. So that's just basically the rule. So in this way, if you're gonna need a lot of one-shot instruction, those tags you need to create it to associate with that. So in this case, I just want to show you a different way to do it. All right. Remember, we talk about the double integer has 32 bits within each tag. Right, so we can use that. So for example, instead of create a Boolean tag, you can see this is a Boolean tag associated with the one shot. I could, right? So I could create I can even call dummy. So I could create a tag name because it's just only for one shot. It doesn't have a lot of meaning, right? So you can create any tag name, right? So for example, over here I create just a dummy. Right, and then over here the type it assume use bool, but this time I will not follow that. I will just set up as double integer, but you know that will create a problem because one shot is a Boolean instruction. When you associate double integer with that, it will not get through, right? So but remember, we have the double integer has 32 bits, right? We can use .0 to get one of the bit. You can see here that red X is gone, right? So it accepted. So if I finalize it, you can see I can use this dummy or whatever name you call that .0 as a bool, as a bool tag to associate with the one shot, because you're going to use a lot of one shot depends on your design. All right. So in this way, you can make it easier, right? So based on that, I believe you can understand how do you process with the deduction, right? So the wrong, and then after that you can see the fault, right? Whenever the fault light turn on, that will be the trigger. Then you have one shot to subtract 5 points on that. All right.